Okay, so thank you all for working on the prerequisite problems before class officially began, but we'll go ahead and jump in. It's 8:40. This is a small class. It's not supposed to be quite as small as what we have right here in front of us. Officially, there are 12 folks enrolled. I think it might still be raining pretty hard. I don't know if the roads are slowing some people down right now, but we're going to jump in and maybe we'll get some stragglers. First of all, welcome to Math 096. On the very first day of class, there are a lot of logistical things to do, so we'll tackle them, but we're going to try not to like bore ourselves with too many of them in one shot. So we're just going to jump in and start doing some math. Because this is such a small class, I wasn't planning on having anybody sit at the back two tables, so if you all are feeling brave and can come on up and join one of the other four tables. Thank you. And if you don't have any of the handouts, you're going to go ahead and grab one of each of four different things on those tables, four different handouts. And so we'll go through all four handouts at some point during class, but for right now, we're going to start on the big packet, which looks like this on the very first page. So let's have the big packet right in front of us. And we'll jump in here, our summary, the math that we're going to do today. In this lesson, we review solving equations and graphing. So for many of us, it's been, I don't know, 3 months since we've done math, maybe more if you had some gap time. Some of you might have had a math class, you know, just a couple weeks ago in the summer session, but I'm guessing that there's some rust developed. So let's see if we can shake off some of that rust and review a little bit about solving equations and graphing. So first thing I want us to do is introduce ourselves. So go ahead and write down the name or names of the people at your table. You got a couple of blank spots there. Go ahead. Okay, so now we know at least one other person in this room. So here's the first math question we're going to work on this semester. So a note here, number 3, unless noted otherwise, the problems in the class packets, like this big packet right here, are intended to be done without a calculator. So for the most part, we're not going to be using calculators. There will be a couple of classes where we'll be doing calculator stuff, and I can lend you one if you don't have one. But by and large, this is not a calculator-based class. I'm sorry to break your hearts right out of the gate, but it is what it is. Okay, so first thing up, this equation, y equals x plus 4. Ultimately, what I want us to do is graph that equation. So we're going to build to that by first filling in the table with 4 solutions to that same equation, y equals x plus 4. The first row has been done already. So I have somewhat arbitrarily picked x equals -5. And if we substitute x equals -5 right in here for this x, and instead of x plus 4, it's a -5 plus 4, which is -1. So apparently when x is -5, y turns out to be -1, and we can write that as a nice, neat ordered pair inside of parentheses. Remember, x always goes first, okay? I have picked 3 other arbitrary x's for you, -2, 0, and 3. Go ahead and fill in the rest of that table. Before you get too far in that table, check in with your neighbors. Let's make sure we're doing it right before we do all the table. And once you finish the table, go ahead and do the rest of the problems on this page. At some point, I'll call us all back together. 1. So I think we did pretty well with filling in the points in the table, and then we plot our points, and then we connect the dots, and lo and behold, we get a straight line. There's not a lot of ways to lose points when you draw a straight line, but there's one thing I want to point out that I will take away points for, is if you draw that straight line. What's the problem with that straight line? Yeah, so arrows is one thing, and in fact, when I was taking this class a bunch of years ago, if I didn't put arrows, the teacher would take points off. I'm not so neurotic that I need to see arrows. There's something else that's a problem with the line that I've drawn. It's got to keep going, right? The line that I drew seems to suggest it stops at my 2 endpoints. And I don't know, this line, y equals x plus 4, does not care what table of points you pick, right? That was somewhat arbitrary. So just make sure that your graphs are extended typically to the edge of the graph paper. If you want to put arrows, that's fine. I'll never take points off for not putting arrows. But if you start and stop at your points, that's a problem for me, okay? So extend all the way. And then the last thing was just a review of the names of the quadrants. So I think I mentioned up here is number 1, and then we go counterclockwise. And typically we use Roman numerals. So which quadrants does our line pass through? 1, 2, and 3. So that's our answer to part D. 1, 2, and 3. Okay, so I think that's everything we're going to do on this page. Let's move on to the next page. And before we jump in, let's take a little bit of pause here and talk about some of the other documents that are on your table. So for example, this one right here is the syllabus. Go ahead and take a quick look at that one. So there's lots and lots of information in this syllabus. Part of your homework for the next couple of days is to read through this syllabus and let me know if you have any questions on anything. I just want to point out 3 things in the syllabus while we're here together. First, my first name is Ian. That is what I want you to call me. I've got my work number listed here. I have my cell number listed there. I'm giving you my cell, which is my way of saying it's okay to call me if you have any questions. In particular, you're welcome to email, but I don't have access to email when I'm at home. And so if you have something that's like there's a test tomorrow and oh my gosh, I have a question, emailing me is not the way to do it, okay? Feel free to call. Sometimes I'll have students working on the homework and they'll like stumble and fumble for 45 minutes on one problem. And if they had just called me, it's like 15 seconds later, I've given them the one little piece of information they were missing and then they can do the rest of the homework, no problem, okay? So stumble and fumble a little bit on your own. But at some point, you know, like just give me a call and we'll get you pushed through. It's probably something minor. Okay, the next thing I wanted to point out on the syllabus has to do with the textbook. So our official textbook, Intermediate Algebra for College Students, the 7th edition. 7th edition of our textbook is quite expensive. The worst part about that is I don't get a cut, which is just so sad, right? Like I should know. Okay, but the 6th edition of our textbook is just fine, and it is quite a bit cheaper. So if you have not yet bought the textbook, I'd encourage you to look around maybe online, see if you can find the 6th edition. Come on in. Yeah. Excellent. Excellent. So either one is okay. The 6th edition is probably going to be quite a bit cheaper, especially if you don't mind a used textbook. It's okay if you need to wait, you know, a few days for a book to be shipped to you if you order online. In the meantime, there is a copy of both editions of our textbook in the Math Studio right across the hallway. So you can work on homework right across the hallway if you can find a way to fit that into your schedule. There's also a copy of our textbook in the library. You can't check it out, but you're welcome to use it in that space, okay? Any questions about the textbook? All right, and then the other thing I wanted to mention in the syllabus is near the end. It's not quite the last page, but it's the second to last page. It's going to be a big old grid. Go ahead and grab one of each of 4 different handouts on the table there. Okay, so there are 2 grids near the end of this syllabus. One of them at the top says Monday, Wednesday, Friday. That's you. The other one, the very last page, says Tuesday, Thursday. That's not you. In fact, if you feel like ripping that last page off so it doesn't distract you, you can throw it in the recycle bin later. That would be okay. Our schedule is the Monday, Wednesday, Friday. And here's what it says. Today is September the 6th. We are doing something called lesson number 1. All the lessons are numbered. We'll get into the flow in the next few classes. It tells you what topic we're covering today, and it also tells you when the homework is due. Now, there's almost always a homework assignment for every single lesson, and it is almost always due the very next class. So typically, today's homework would be due at the start of Friday's class. But because I know we don't all have our textbook yet, I'm going to try to give you guys a little bit of wiggle room and give you a week on today's homework. But if you have the textbook or you can find time to just do your homework in the studio, I want you to do this for me before Friday, all right? Don't like leave it for a week. That is not the norm. So these first 3 homework assignments are all going to be due on the 13th officially, but do them as soon as you are able. And then once we get past this little beginning of the semester, then it'll just be due the very next class, okay? All right, so I think that's good there. If you are super organized, you can feel free to add the dates of our tests and quests into your calendar. For example, test 1 is October 18th. All the dates are there. If we have snow days, things will change a little bit, but that's the calendar that we're planning right now. Okay, that was a lot of information. Any questions on anything at this moment? Okay, next thing to talk about is something you don't have in front of you, so don't look for it. This is a flow chart of all the math courses offered here at GCC, and I just want to make sure that everybody in this room is in the right spot. So currently, you are here, Math 096. Math 096 is a fine course. It opens the door to a bunch of other math courses. In particular, after taking 096, you are qualified for statistics. So if you're headed that way, then you're in the right spot here. Or you could take college algebra, which opens the door to pre-calculus and calculus and beyond. So if you're headed down a mathy track, engineering, science, any of that stuff, then again, this is the right spot for you. If you are a nursing major or other health science major, this is the right spot for you. However, Math 096 does not fulfill the math requirements for our liberal arts general associate's degree. So if your sole purpose for taking this math class is to fulfill the math requirement of your associate's degree, this ain't it. Another possibility, and I suspect all of you or almost all of you would qualify for this class right now this semester, is Math 117, which is mathematical problem solving. The benefit of Math 117 is that it does fulfill the liberal arts general math requirement, and you could take it right now almost certainly. It's possible one of you doesn't qualify for it, but I'm guessing all of you or almost all of you could take this one this semester instead of 096. Again, the benefit there is that you are getting your math requirement done in one semester as opposed to 096 and then one other course. The downside is you can see nothing branches off of Math 117. It is a dead end, whereas 096 opens the door to a lot of courses. Pretty much which course you belong in, this one, 096 or 117, is determined by your major. So if you are not at all sure whether or not this is the right spot for you, just chat with me right after class, and we'll make sure that we get you in the right spot, whether that means staying here or switching. Okay? Yes?
You're a nursing major and you're
I think nursing majors need 096 to get into A and P. I think that's the most common thing.
you were working on your course.
You still need another, I don't know that I would take 117, probably statistics or college algebra. But yes, this one and one more. Okay. All right, so good. I think that's everything there. Oh, one quick thing. A bunch of us were working on this key prerequisite sheet. It's a one-page handout on your page. It was just something to try to shake off a little bit of the rust. I would like you to work on this outside of class at some point as you're able. I'm never going to collect it, but if this sheet is particularly difficult for you, then let's chat right away and make sure that this is the right spot for you, or that I can give you some resources to get you back into the swing of things after a summer off from doing mathematics, okay? So I'm not going to collect it, but if it's problematic for you, talk to me. We'll figure things out together. Okay, so I think that is good there. Let's come back to the big packet. And we left off right here on page 2. All right, and we are going to take a look at solving a quite complicated equation. This one right here at the top. Half x equals 5/3 times x minus 65 in parentheses. So it turns out there's a couple of different techniques we can use to solve this one. I think one of them is much easier than the other one. So I'm going to encourage you to go with the easier one, but let's take a look at both real quick here. Like I said, the solutions are all written out, so we're just going to be kind of reading as opposed to like filling them out together. So one thing we could do with this 5/3 is what? Like a number on the outside of like parentheses. What kind of math thing have you done in that case before? I'll give you one without a fraction. What could you do here? You could distribute, yeah? So we've all seen that before, right? 2 times x, 2 times 5, put a plus sign in the middle, and we're done, right? And so you could do exactly that with this 5/3, right? 5/3 times x, 5/3 times 65, put a subtraction symbol in between. And that's exactly what's written out in this next line right here. 5/3 times x, and then 5/3 times 65. This kind of mysterious number is 5/3 times 65. So in order to get there, you got to be able to multiply fractions. So over here on the side real quick, 5/3 times 65. Do we need a common denominator? No, we need a common denominator when we add or subtract fractions, but to multiply fractions, well, let's force this 65 to look like a fraction. And then how do we multiply? Straight across, right? And so on the bottom, 3 times 1, that's easy. And on the top, 5 times that, 325. Okay, that's where the 325/3 came from, all right? Okay, next thing we need to deal with is the fact that there are x's on both sides of this equation. We don't want that. We're going to get all the x terms to one side and all the not x terms to the other side. So in this case, I think the best thing to do is to move this 5/3 x to the left-hand side by subtracting 5/3 x from both sides. Fair? So over here, it used to be a half x, and now we subtract 5/3 x. Now it's on the left-hand side. And on the right-hand side, we used to have a 5/3 x, but we just subtracted it, so it disappears entirely. So we just have negative 325 over 3. Okay, next up is to combine those two terms. Again, fractions can be a little bit intimidating for some of us. I'll give you one without fractions. How much is 7x minus 4x? It's 3x, right? We just do 7 minus 4, and then the x is just hanging out. Okay, I see this complicated thing with fractions as being just another example of 7x minus 4x. The 7 is like the half. The 4 is like the 5/3. According to what we did here in purple, all we got to do is calculate 7 minus 4 and then tack an x on the end. So I guess over here what we're supposed to do is a half minus 5/3, right? Half minus 5/3, and then tack an x onto the end. Okay, easier said than done. We got to subtract fractions. What do we need to build? We need a common denominator here because we're adding or subtracting fractions. Fair enough. Let's find our common denominator. 2 and 3, what's the common denominator? 6. So we got to make both of these fractions turn into the same number. 6 is the best number in this case. What do you need to multiply the 2 by to turn it into the 6? It's 3. So if you multiply the bottom of a fraction by 3, right away you multiply the top of the fraction by 3 as well. 1 times the 3 is 3. Is 3/6 equal to half? Yeah, we haven't cheated, right? It's still equal to what it was before. It's just written in a better form for us. Same deal over here, 5/3. What are we multiplying the 3 by to turn it into the 6? Is it 2? So you better multiply the top by 2 as well, which gives us 10. And again, you can check if you reduce 10/6, what do you get? 5/3, still equal, but now the fractions talk to each other much more nicely. Okay, upstairs, 3 minus 10 is -7. Downstairs, do we do 6 minus 6? I sure hope not. That would be dividing by 0, which is a problem. What's the new denominator? 6, right? We don't do anything to that. So we get -7/6. But remember, it was just an example of like 7x minus 4x. We just did the subtraction. 7 minus 4 gave us 3, and then we tack an x. -7/6 is our final answer, but then we tack on the x. -7/6x. I told you there was an easy way and a hard way, right? This is the hard way. We're going through this so that we can appreciate the easy way, and I'm hoping to convince you to go that direction. Let's finish here. One last step. I currently have -7/6x. I'm trying to get rid of that -7/6. One option, you don't need to write this, would be to divide both sides by -7/6. That would get rid of it. The problem is, on the right-hand side, we got a big old mess. -325/3 divided by -7/6. That's a little bit hideous. Here's maybe another option. We're going to multiply by something instead of dividing by something. We're going to multiply by -6/7. Anybody remember the fancy math word? What is it? Reciprocal. Excellent. Multiply by the reciprocal. Good things will happen. Whatever you do to one side, you better do to the other. So both sides times -6/7. And then the most satisfying part of this problem, what happens with the 6's? They cancel, right? Top and bottom. What happens with the 7's? They cancel. And what about a negative times a negative? That's a positive. So the only thing remaining on the left-hand side is x, which is great. That means we're pretty much done with this problem. So x equals -325/3 times -6/7. And then we know how to multiply fractions. No common denominator, just straight across. Turns out to be 650/7. Again, two negatives multiplied give a positive. Phew. Okay, so that's option 1. Here's option 2. It's much nicer. The very first thing we did before was distribute that 5/3. Well, the effect that had was making more fractions, right? Because we had just a single 5/3, and then the 5/3 became fractions on both the x and the 65. Here's another possibility. Let's get rid of the fractions straight off the bat, because that's what made this problem kind of challenging. Okay, looking at the two denominators, I see a 2, I see a 3. What is the common denominator for those two fractions? 6. We are going to multiply both sides by 6. We're not making a common denominator of 6. I don't want to make any denominators. I want to get rid of those denominators. And the way to do that is to multiply both sides by the lowest common denominator. So here it is, times 6 times 6. We'll highlight that's the new thing. Everything else in that equation is just copied from up above. And then magic happens. 6 divided by 2 is 3. So the left-hand side is just 3 times 1 times x. 3x. Fair? The right-hand side. 6, okay, you could do 6 times 5. That's 30 and divided by 3, but I always prefer to reduce first before I multiply. 6 divided by 3 is 2. 2 times 5 is 10. That's right there. And what have we gotten rid of? Fractions. And this problem is a whole heck of a lot more user-friendly than the original. Okay, so the rest of this is pretty quick. We're not going to go through it all. Distribute the 10. Now I have x's on both sides, so subtract 10x from both sides. And then finally divide by -7, cancel the negatives. Of course, we'll get the same answer, 650 over 7, but my goodness, that was a whole lot less painful. Okay, so I think that is good there. Moving on to the next page. And here are the activities. The activities are going to be what we spend most of our class time on, and it's going to be you guys working with your neighbors. So I'll read this note one time here. Working and struggling through the activities on your own or with your table mates will increase your understanding of algebra immensely. An answer key usually follows the activities, but check your answers with your neighbors before checking with the answer key. I'll say that again. I much prefer you check with your neighbors before you jump to the answer key. So the answer key is like second line of defense, but it's going to be much better in terms of your understanding of algebra to talk about differences in answers with each other than to just jump to my key, okay? If everybody at your table is stuck, you raise one of those little flags and I will come running over, all right? Okay, so you're going to work through these equations. When you finish these equations, you turn the page, you will find more equations. You just keep turning the page until I call us all back together in a little bit. Oh, there is a room to check your answers here. You don't need to do that, but there's space there if you want to do it. And let's go ahead and jump to this page right here, which is page 5. Everybody jump to page 5 real quick. And so we're doing great work on the equations, and once we finish this, I'm going to have you go right back to where you were and keep on working on those equations. But this is a different kind of problem here on page 5. So let's just do one of these together, and then you can do the rest on your own or with your neighbors. All right, so here it is. It says use the graph of this line, y equals -2.9 times 0.315, blah, 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 blah. A lot more complicated than any of the equations that we've been playing with today. It says use the graph to solve the following equation. So here it is. 5 equals -2.9 plus 0.315, blah, blah, blah. All right. So I could ask you to like use straight up algebra to solve this thing. That would be complicated. Lots of stuff we'd have to do. I guess we'd have to distribute there. Then you'd have some term with x here and some term with x here, so you got to smush them together. There's decimals floating around. It's a little bit messy. And then you're going to have to combine the not x terms like those guys. That one doesn't have an x, so eventually you get it so there's just x's on one side, just numbers on the other side. It's a big process. Turns out if you have a graph, it's actually pretty easy if you know what you're doing. In fact, these are going to be the easiest problems for today if you know what you're doing. So here we go. Let's take a look at this diagonal line. So this is given to us in this problem. It says this is the graph of y equals all of this stuff. Earlier today, we graphed an equation together. I think it was y equals x plus 4. This is just another line, y equals all of that complicated stuff. And let's take a look at the relationship between the complicated things on the right-hand sides, right here and right here. So if you look at them piece by piece, you will be able to convince yourself they're exactly the same. And that is no coincidence. So apparently these two equations are the same, except that instead of y, you have the solitary number 5. That's the only difference between those two big equations, is that the y has become a 5. Okay, well this is a graphical kind of problem, so let's look at the graph. I'm going to find points where the y is equal to 5, because that's what I'm interested in. For example, how much is y right there? 5. Is that the only spot on this grid where y is equal to 5? It's not. For example, how much is y right there? It's 5. And how much is y way over there? It's 5. And so there's infinitely many spots where y is equal to 5. In fact, it's that horizontal line right there, right? And so what we're interested in is finding a point that's on our diagonal line, that's the crazy graph that we're given here, where the y is equal to 5. Do you see the one spot on this diagonal line where the y is equal to 5? Hopefully we do. It's right here. That's the one point on our diagonal line where the y equals 5. Go ahead and draw a little arrow up there from the 5 right over to the diagonal line. But then again, take a look at our original equation here in part A. What's the only variable in that equation? It's x. Us saying y equals 5 was just for our convenience, but the final answer to this equation has to look like x equals a number, just like all the equations you've been solving for me today. So what we're interested in is how much is x at that point on the diagonal line? Can you approximate it? How much is x at that point? Negative 2.75, does that seem reasonable? All right, we take that point, we go straight down to the x-axis and land somewhere around negative 2.7, negative 2.8, something like that. And that's it, that's our answer. X equals negative 2.7, 2.8. I heard negative 2.75, so that's what I'll write. What's that? Yeah, it's like you don't have to do any like pure algebra, right? We didn't solve the equation by adding the same thing to both sides or dividing both sides by a number, right? We just looked at the graph. So if you have a graph, then approximating answers is pretty easy. Do you think the right answer is exactly negative 2.75? I don't know, maybe. I wouldn't put a lot of money on it, right? Like anything we do with the graph is going to be approximations. But that's all this question is asking us to do. So if you said negative 2.7, full credit. If you said negative 2.8, that's full credit. If you said negative 3.1, that's no credit. I mean, like there is a range of right answers, but you got to show me that you're in the ballpark here, okay? All right, go ahead and answer the other 3 questions in this part right now. Check in with your neighbors. Make sure you write all the answers in the form x equals. I mentioned earlier that our class is always going to have the same kind of flow, and we will get into that flow in the next few classes, but I just want to give us like a broad sense of like, you know, here's how our class is going to generally go. The beginning of class is going to be the demonstration. That's me kind of leading the way up here and illustrating the concepts for the day. That's hopefully going to be a fairly small part of the class. And then after the demonstration, you will find the thing that says activities. That is what the bulk of our class is going to be spent on. You worked great with each other today. You're going to continue to do that all semester. I expect that folks are going to finish the problems in the activities. It may or may not happen in class. There are going to be some speed demons who get through all the activities in class. I think some of our groups were pretty close to finishing. It's okay if we didn't finish. But if you didn't finish, I would hope that you could find some time outside of class to finish. And I hope that there isn't too much left to finish at the end of each class. I'm not trying to like give you too much stuff to do. But then if you go a few pages down the road, so everybody find this page here, it says even more practice at the top. So what page is this on? I think you're too far. Page 6. So on page 6 is even more practice. It says the even more practice problems are optional. They are there for the speed demons who finish everything in the activities during class and need something else to do. If you finish a problem, I will find more problems for you to do. The right thing to do when you finish a page is almost always go to the next page. But I don't need you to do these. They're there for the speed demons and also for folks who just want some more practice. If you feel like you didn't quite get what you needed to get in the activities, you'll find even more practice problems a few pages down the road, and every one of those sections has an answer key as well, okay? So just about every problem in this packet has an answer key. On the very next page is a collection of learning objectives. Some folks just ignore this thing. I don't think you should. I think it'd be great to take a look at them. For example, F, it says, after participating in this lesson and completing the homework assignment, you will multiply equations with fractions by the least common multiple of the denominators. We saw that today. If you know how to do that, great, you got what you needed to get. If you don't know what I'm talking about there, that's an indication that you need to do more practice and be asking me, hey, Ian, can you give me some examples of things like that? Okay, last thing for today, I think we're going to go like 30 seconds over, and I apologize. But take a look at the homework packet, which is one of the 4 handouts. Go ahead and grab one of those right now. So here is the homework that is due on Friday. If you have the 6th edition, you are going into your textbook in section 1.3 and doing problems 5 and 47, etc., and also section 1.4, all of that stuff. We just did lesson 1. Homework is almost always due the very next class. If you have the 7th edition, it's a different collection of problems. Just make sure you're looking at the right collection of homework assignments, okay? Like I said, almost always do the very next class. If you have access to a textbook now, do them for me. Show me this homework at the start of class on Friday. Write out your work just like you did here. Don't just write x equals 17. I gave you odd problems so you can check your answers. But don't just write the answer. Show me the algebra. I will walk around before class on Friday and check it. But again, we'll give you like a 1-week grace period just here in the beginning while we make sure we have access to our book. Okay? We'll see you guys on Friday. Have a great day.